Hello friends, so we have discussed earlier that what is systems, what is surroundings, and there are different types of systems, that open system, closed system and isolated system. All these we have discussed earlier in the first video. Now we have to study about what is the properties of different systems. What are the properties? So there are two properties of a system, that are extensive property and intensive property. That is, for a system there are a system. So what is extensive property? Extensive property means mass dependent property. Mass dependent means this is what the amount of materials present in the system, that is the amount of materials present in the system, that is called the mass dependent. That is the amount of materials present in the system, in which this is called the extensive property. What are the extensive properties? Example, that is mole number n. This defines the amount of materials present. So this is extensive property. Another one, internal energy U, enthalpy H, and there are other thermodynamics property, other thermodynamic properties. These are extensive property, that is the properties which are dependent on the mass or the amount of materials present. Another will volume, mass. These are also the heat capacity. These all are extensive property. Now the other property is intensive property. Intensive means it is independent of the amount of material present. That is independent of amount of materials present. That is amount of materials, it is not dependent on the amount of materials present on that system. So it is called the intensive property. So what are the examples of intensive properties? These are like temperature. We know all the temperature is not dependent on mass or any amount of material. Pressure is also intensive. Density means mass by volume. That is, this is extensive and this is extensive. So extensive ratio cancels out and it will become an intensive property. Mass extensive and volume itself extensive, so cancel out and it will become an intensive property. So density is the intensive property. Another, refractive index. Viscosity of fluids, which is denoted at eta, viscosity. Another one is surface tension. Another concentration means it will also to extensive, it is also the fraction of to extensive property, that's why it is an intensive property. And all the molar properties are intensive. All the molar properties are intensive. Why all the molar properties are intensive? Because that are divided by mole number. That is the ratio. It's become the ratio of two extensive property, and we have discussed that two extensive properties ratio is an intensive property. That's why all the molar properties are intensive property, like molar volume, molar mass, molar enthalpy, molar entropy. These all are intensive property because these are the ratio of two extensive properties. That's why these are called intensive property. Now another things we have to discuss, that is how to define a system, how to define a state of a system. We have studied the system, but how to define that what is the state of that system. So to define a state of a system, we have to know different variables. We have to know some variables of that system. So to know the system, we have to know the different variables of that system. What are those? Pressure, temperature, volume, and mole number, that is N. But in thermodynamics, we will consider that it is a closed system. Generally, we consider it closed or isolated system. For thermodynamics, closed system or isolated system. For thermodynamics, we will study the closed system and isolated system generally for classical thermodynamics. And in those closed system and isolated system, what is this? The N number, that is N is fixed, that is mole number fixed, that is mass not exchanged. We have said that in case of closed system and isolated system, that mass number does not change, that is mass remains fixed. Thus we have to study the variables like pressure, temperature, and volume. These three terms we have to study to know the state of a system. Clear? So if we want to know the state of any system, we have to know the pressure, temperature, and volume of that system. Now we have to discuss the different thermodynamic parameter or thermodynamic properties. What are those? Work, heat, internal energy. We have to know about this term. So at first we start with work. So what is work? Now, work, when an object is displaced through a distance, through distance like something dx against a force, that is called work. What is? If a substance, this is a substance, this is displaced from here to here, let's say its distance is dx against a force F. When we apply a force F on this substance will displace a little amount, that is we have to, let's say dx, and this is the displacement. So against some force, if a substance displaced some distance, then it is called work. This is the mechanical work. Sorry, this is non-mechanical. This is called non-mechanical work. What is this? Work equal to F opposing into distance travel, that is displacement. W equal to F opposing into distance traveled, that is displacement. F opposing means the displacement against displacement. Force is applied against the displacement. It is force is applied here in this direction, and the displacement occurs in this direction. So this is a non-mechanical work. Another different type of work are there. One is called mechanical work. This is non-mechanical. Non-mechanical means non-PV, non-pressure volume not involved in this case. But this is mechanical work. Mechanical work means the air pressure and volume is involved. That is if we applied some pressure like P opposing, then in the system there is some volume change, that is called dV. Then this work done is called pressure volume work, that is W equal to P opposing into dV. This is called pressure volume work, and it is called the mechanical work. This is actually thermodynamical work. So actually, if we consider a thermodynamic work, what is thermodynamic work? Now, thermodynamic work is one of the principal process by which a thermodynamic state can interconvert it with its surrounding. So thermodynamic work means it is the principal process by which a thermodynamic system can interconvert or interchange with its surrounding. So thermodynamic work is the principal process by which any thermodynamic systems can interchange with its surrounding. Maybe it's some heat energy or some other. So it is called thermodynamic work. Another work is gravitational work. What is gravitational work? We know that is mgh, where g is the acceleration or the gravitational acceleration, h is the height, and m is the mass. So this is gravitational work. Another work is electrical work. What is that? Q into dE. Q means charge and D is the potential difference. But here we only study about the thermodynamic work. Thermodynamic work means a thermodynamic systems where a thermodynamic systems interchange with its surrounding. That is the mechanical work. That is PV work. With applied some pressure, there is some volume change in the system. That is the mechanical work. We will study this work only here in thermodynamics. So now, what is heat? The heat is a form of energy. Heat is a special form of energy. Heat is a special form of energy. It can produce from work. This heat can produce from any work or it can be partly converted into work. It can be partly converted into work. What does it mean? Now, if we applied some heat, then any work is possible. If some work is done, then we have to apply some heat. Again, this applied heat is converted into work. So heat is another form of energy. Again, all other forms of energy can easily be converted into heat energy. This term we should know. All other forms of energy can easily be converted to heat energy. That is, all other forms of energy can easily be converted into heat energy, but heat energy cannot be converted to all other energy. Heat energy cannot be converted to other energy, to other forms of energy. That means there are different type of heat energy, but there are different type of energy like enthalpy, entropy, but from all that energy we can convert it into heat energy, but heat energy cannot be converted to other energy. So this is heat. Now we have to study internal energy. What is internal energy? What is internal energy? Which is denoted as U. So internal energy is the energy that contains within the molecule. It contains, that is, the energy contains within the molecule. Or within the system, or any system. That is, the energy contained within the molecule or in the system. We can say that a system, by virtue of its existence, must possess some store of energy. This energy is called internal energy. So internal energy is basically, it is the sum of potential energy plus kinetic energy present in the molecule. So in a molecule, there is some, in a molecule, for the existence of that molecule, there should be some potential energy and there should be some kinetic energy inside the molecule, and that energy is the characteristics of that molecule or that system. This is called the internal energy. So it is the sum of the potential energy and the kinetic energy present inside the molecule. So this stored up energy, actually this is the stored up energy. This is the stored up energy inside the molecule. This is the stored up energy inside the molecule. Now we have to study a point that is related with this thermodynamics, and it is useful to study this chapter. What is this? The perfectly differential quantity. perfectly differential quantity. What is the meaning of this? Let's say X is a quantity. It can be enthalpy, internal energy, entropy, like that. So X can be any type of quantity. Now we have to understand, is that quantity is perfectly differential or not. Perfectly differential means if we differentiate, there is some value, or it can be it can be differentiable or not. So this is why we have to study this. So how we understand that? So the quantity, if we say that if the quantity is perfectly differential, then there must be three types. So to satisfy this perfectly differential quantity condition, the X must be, if this is a perfectly differential quantity, then that X must be a state function and single valued. What is meant by state function? State function means it will depend on the states. That is, what is the state of the system? That is, it is depend on the state, not on the path. That is, on which path the system is goes, or on which direction it is goes. It not depends on that. It will depend only on that system. That is, what is the state of the system. Like if we said that is liquid or gas, this type of, that is what is the state of the system. So it must be a state function and a single value. That is, after differentiation it must give a single value. Again, another one, dx, that is change of that system, will be independent of path of the transformation. That is, if X is the quantity and it is transformed to another form, let's say x1, so it will depend only on that state, not the path, how the path is going from x to x1. It will not depend on that path. It will depend on the states only in which it is stay. So dx, that is change from here to here, is independent of the path of the transformation. If x to x1 goes through this path, or it goes through this path, or is straight line path, it will not depend on that. It will only depend on the state, not the path. So dx is independent of the path of the transformation. Again, it can be denoted like cyclic integral dx equal to 0. Cyclic means if we say that x to x1 goes from x to x1, this is a cyclic path, like here to here, then the the integration of cyclic whole integral will be 0. As we said that dx will not depend on the path of the transformation. So as it is independent, so the whole integral, that is whole path integral, will be 0. That is, the change of the x of the system in the cyclic process is 0. That is the change of x in the cyclic process is 0. That is, it will only depend on the final and initial state, not depend on what path it is going. So the change will be always x1 minus x, that is final minus initial state, not on that path. So cyclic process, if we consider that change in cyclic process, it will be 0. So these are three parameters, and it can also write as